Okay, Wildcat 7.2, make the best of it, optimization. All right, let's go and take a look at the warm-up. All right, graph each linear inequality. Okay, so to graph this, we start with the y-intercept, which is -1. So that's the point 0, -1. And then we look at slope. Well, slope is the number in front of x, so we're going to put a 1, but slope is always a fraction because it's rise over run, so we're going to divide it by 1. So that means we go up 1 to the right 1. So we go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Okay? Now, there's no line underneath, so that's a dashed line. And then it's greater than, so it's shaded above. Okay, so let's go ahead and do that. Okay, let's take a look at question number 2. So we start at the y-intercept 0, 2, and our slope tells us we go down 1 to the right 2. So down 1 to the right 2, down 1 to the right 2. There's a line east, so it's a solid line. And it's less than, so it's shaded below. All right, go ahead and finish up questions 1 and 2. All right, let's take a look at the next page. All right, getting started. She works hard for the money. Recall that you can graph a linear inequality in 2 variables on a coordinate plane by determining the boundary line and shading the appropriate half plane. 1. Janice works 2 jobs and is trying to maximize her weekly earning. Her babysitting job pays $10 per hour, and her job at the ice cream shop pays $7.50 per hour. Suppose she needs to earn at least $90 to cover her weekly expenses. A. Write a linear inequality represents the total amount of money Janice needs to earn at her jobs. Be sure to define your variables. Let's define X as the number of hours babysitting and Y as the number of hours at the ice cream shop. And our inequality will be 10x plus 7.5y greater than or equal to 90. All right, let's go ahead and graph that, and let's go ahead and use Desmos. So I'm going to come over here, Desmos. I'm going to type in 10x plus 7.5y, and then I'm going to come over here, greater than or equal to 90. Now, our Desmos window doesn't look like the paper, so we need to adjust that. So I'm going to come over here. We can see we're going from 0 to 40 and 0 to 30. So I'm going to come over back to Desmos, click on the wrench. So the x-axis is going from 0 to 40, and the y-axis is going from 0 to 30. At that point, I'm going to zoom out just a hair. And now I have my graph. I need 2 points, so let's click here and here. So let's go ahead and graph 0, 12, and 9, 0. So these are counting by 2, so 2, 4, 6, 8, 10, 12, so 12, 0. And then 2, 4, 6, 8, 9 is between 8 and 10. We know it's a solid line and shaded above. All right, go ahead and finish up your graph. All right, let's take a look at the next page. C. Janice's friend Colin suggests that she work 18 hours at her babysitting job and 12 hours at the ice cream shop. If Janice follows Colin's advice, will she earn enough money to cover her weekly expenses? Okay, so let's let x equal 18 and y equals 12. And we're going to use the inequality 10x plus 7.5y is greater than or equal to 90. Okay, so now let's go ahead and substitute x and y into the inequality. So that's 10 times 18 plus 7.5 times 12 is greater than or equal to 90. And let's see if that's true or false. So I'm going to go to another decimal screen, and I want to go to Scientific Calculator, and I'm going to do 10 times 18 plus 7.5 times 12, and I get 270. So 270, that is true, so it checks. So D says write the solution as an ordered pair. What does it fall in the graph? So the solution is 18, 12. Let's find out if it falls in the graph by graphing the point. So I'm going to come back to the graph. So 12, 14, 16, 18. So 18, 12 is in the shaded region. So it does fall in the shaded region. So it is a solution. So it falls within the shaded region on the graph and is a solution. All right. Go ahead and mark out E, and let's take a look at F. Why is the graph restricted to the first quadrant? The graph is restricted to the first quadrant because the number of hours worked cannot be negative. Write two inequalities that represent this restriction. X is greater than or equal to 0, and Y is greater than or equal to 0. All right, let's take a look at the next page. Activity 2.1, Systems of Linear Inequalities. The three inequalities you wrote to represent the possible number of hours Janice can work at her job make up a system of linear inequalities. How does adding another inequality to the system affect the solution? 1. Suppose that Janice can work a maximum of 20 total hours per week. A. Write a linear inequality that represents the total number of hours that Janice can work per week. So that inequality is x plus y less than or equal to 20. B. Is Colton's suggestion of 18 hours at her babysitting job and 12 hours at her ice cream job still reasonable? Colton's suggestion is not reasonable because if we substitute x equals 18 and y equals 12 into this inequality, so we have 18 plus 12 less than or equal to 20. Rewrite that. Then we have 18 plus 12 is 30 less than or equal to 20, which is false. So it's not true. All right, let's take a look at C. Write the four linear inequalities that you have written into a system of inequalities that represent Janice's problem. So inequality number 1 is x plus y less than or equal to 20. Our inequality number 2 is 10x plus 7.5y greater than or equal to 90. Our inequality 3 is x greater than or equal to 0, and our inequality 4 is y greater than or equal to 0. Okay? Now, let's go ahead and do each of those in a different color. So I'm going to do 1 in orange. Okay, so let's go ahead and graph that in Desmos. Now, we actually have this one already graphed, so let's go ahead and do that one, okay, first. So I'm going to come back. Let's go ahead and do this one. I'm going to do in green. Okay. Now, in Desmos, I can actually change the color of this. So I'm going to come over here to this little wheel looking thing, click on the color, and I'm going to change that to green. Okay. So solid line, shading in green. So let's go ahead and do that. And let's get the point. So we got them before. Let's do it again. So we have 0, 12, and 9, 0. Okay. So 0, 12, 8, 9. Okay. Okay. Now let's go back up to 1. Let's go ahead and graph 1 in orange. So I'm going to do that. So x plus y now I'm going to come over here to the wrench, click here, and make that orange. Now we need points for the line, so we're going to here, so we have 0, 20, and 20, 0. So 0, 20, and 20, 0. Solid line, we're going to do this in orange. Now, you see that the shaded region overlaps. So far, that's our solution, okay? And then we're going to do x is greater than or equal to 0 in pencil. And we're going to do y greater than or equal to 0 in pencil. Okay, so this is y greater than or equal to 0. And you're shading everything above. And this is getting darker. So still our solution. And then so our overlapping region is this piece right here. And that's our solution. All right, go ahead and finish up the graph. All right, let's take a look at E. Suppose that Denise is only able to babysit for 6 hours. How many hours must she work at the ice cream shop in order to meet her earning requirement? Okay, so we're going to solve for y when x is 6. So we're going to substitute 6 into the equation. So that's 10 times 6 plus 7.5y. We're going to set equal to 90. Well, 10 times 6 is 60. Plus 7.5y equals 90. We're going to subtract 60 from both sides. This becomes 0. We're in a room, so we're going to move over here. And then we have 7.5y equals 30. divide 7.5 by both sides. So y equals, and I can come back over here to Desmos. Is 4. Okay, so y equals 4. So Janice must work 4 hours to meet her earning requirement. Okay, let's take a look at the next page. All right, so write your solution as an ordered pair. So the solution was x is 6, y is 4. So the point would be 6, comma 4. And I marked it out, but we can relook at that. We can see where it falls. So let's go ahead and graph. Actually, yeah, we can graph that. All right. So 2, 4, 6, 2, 4. So 6, 4 lies on the line, and if it's on the line, it's a solution. So the graph verifies that that is a valid solution. Let's take a look at the next page. All right, number 4. Serena and Adam were each asked to graph the system of linear inequalities shown. Serena, the two inequalities do not overlap and therefore the system has no solution. Adam, the solution to the system of inequalities falls in between the two lines. Who is correct? Justify your reasoning. Serena is correct because the shading and the lines are correct. All right, let's take some notes. When y is greater than x, it's shaded above and it's a dashed line. When y is less than x, it's shaded below and it's a dashed line. When y is let me rewrite this. When y is greater than or equal to x, it's shaded above and it's a solid line. When y is less than or equal to x, it's shaded below and it's a solid line. All right, go ahead and mark out 5 and 6. All right, let's take a look at the next page. All right, number 7. The Whistling Baker is a bakery that specializes in cupcakes and muffins. They sell cupcakes for $2 each and muffins for $1.25 each. The Whistling Bakery can take a total of 8 dozen treats each day and needs to make $100 per day. Write a system of linear inequalities to represent this problem situation. Be sure to find your variables. Okay, so let's go and define x and y. X is the number of cupcakes and y is the number of muffins. Okay, so let's go ahead and graph this. We're going to graph this one first in orange. So I'm going to go back to Desmos. I'm going to exit out, press the home screen, starting basically from scratch. So I'm going to type in 2x plus 1.25y 100. Now, I don't see the graph. That's because we need to adjust our window. So we're going from 0 to 90 and 0 to 90. So I'm going to come back over here and we go to the wrench. And we go 0 to 90 and 0 to 90. Okay, zoom out just a hair. I need points. Let's use this point and this point. So 0, 80 and 50, 0. And we see that that is a solid line, and we want to change the color of that. We're going to change that to orange. Okay, so again, 0, 80, 50, 0. Solid line shaded, so let's go ahead and do that. All right. Now let's take a look at the next inequality, and let's go ahead and do that in green. So we have x plus y six, and they did purple, but I want to change that to green. Okay, and I need 2 points. So it looks like 0, 96 and 96, 0. So you're going to have to approximate. So we're counting by 5. So 70, 75, 80, 85, 90, 95, 100. So 0, 96 is somewhere here. And then same thing here. This would be 95. This would be 100. So somewhere right there. And again, we're going to shade. So far, our solution is a overlapping shaded region, but we need to graph x is greater than or equal to 0, and we'll do that in pencil, and y greater than or equal to 0. So we have y greater than or equal to 0, so we're shading above. Still, the only overlapping region for all those shades is this piece right here, and then x greater than or equal to 0, and we shade this way. So our overlapping region is this piece right here. Alright, go ahead and finish it up. Alright, let's take a look at the next page. Go ahead and mark out this page. Go ahead and mark out this page. Go ahead and mark out this page. All right, the student works question 1, 2, 3, 4, and 5, and 6. And to help you out on number 1, I'm going to kind of color coordinate some of the information. So this should help you answer the question in Edge Elastic, or pair assessment, whatever they call it now. All right, and then go ahead and mark out this, and then I've added a few questions to this. So if you would write these down and then answer it in Edge Elastic or pair assessment, whatever the name is called now. All right, so write that down and go ahead and finish your assignment and have a wonderful Wildcat day.